Today's notes deal with Chapter 2, Section 2, the Sun. The first topic we want to discuss is the structure of the Sun. The Sun is divided up into 6 different layers, the first of which is called the corona. The corona is the Sun's outermost layer. This layer creates an atmosphere that is actually 10 to 12 times the diameter of the Sun itself. And remember, we talked earlier in the week that the Sun will hold 1.3 million Earths. So an atmosphere that is 10 to 12 times greater than that is pretty amazing. The next layer in is what we call the chromosphere. The chromosphere is actually a very thin layer at 3,000 kilometers. Now that might not sound really thin, but in comparison to everything else in the Sun, it's actually a very tiny layer. The next layer is actually the one that we're most familiar with, and I'll tell you why in just a second, but that is called the photosphere. The reason that we're most familiar with this area is it's actually the area that we can see. So we call that the visible area. The reason that this area becomes visible is that the gases are actually thick enough to see. Now, that may sound weird when we talk about gases and being able to see them, but again, remember there's a lot going on here, okay? And here they are going to be close enough and thick enough to create, an area that's actually visible to us. The next layer in is called the convection zone. In the convection zone, gases are going to circulate in convection currents. If you remember back when we talked about heat and energy, that means that the warmer gases are going to want to rise up at the same time that as gases are cooling, they want to sink. And again, nothing ever in the Sun is going to be considered to be very cool, but remember, it's all relative. Just like we talked before, it depends on where you're at. Hot and cold is a relative term. The next zone in is the radiative zone. Here we find the atoms extremely closely packed together. The atoms are so tightly packed that it actually causes the light to bounce around in there, and it may take up to millions of years for it to actually get out of that area. The final area is the center of the Sun, which, just like the Earth, we call the core. As you might imagine, the center of the Sun is considered to be extremely hot, so hot that it's believed to be 15 million degrees Celsius, which equals out to about 27 million degrees Fahrenheit. This, as one might guess, is the source of the Sun's energy. Now we want to talk for a minute about that energy production. First, we want to make it clear that the Sun is actually not burning. Einstein helped explain this by demonstrating how matter can be converted to energy. This led us to one of the most famous equations ever with his E equals mc squared, where E equals energy, m equals mass, and c equals the speed of light. This led us to a process that we now call nuclear fusion. This is a process where 2 small nuclei are going to do just that, fuse, meaning put together. For example, 2 hydrogen nuclei running into each other and producing helium. This process produces a great deal of energy. Now, during this process, some energy is actually released, and we call that energy a photon. This is ultimately what will travel, what we'll be able to see and what we will be able to use here on Earth. This leads us to a little bit of atomic review. Again, there are subatomic particles, but for what we're discussing, an atom we consider the smallest part of matter. The atom's nucleus, remember, contains protons, which have a positive charge, and neutrons, which have no charge. The negatively charged electrons are found in valence or shells around the nucleus. Atoms get their chemical identity, so what they are and how they act as far as bonding and other things, from the number of protons and their number of electrons. That concludes the notes for Section 2.